Yesterday, I've managed to connect TFT display and the control buttons to ESP8266 microcontroller, and then I've wrote a simple program to draw pixels. And my plan for today and tomorrow is to display a snake on the screen, make it move, and control its moving direction with the buttons. Hey, welcome to day 48 of 100 Days of Code in IoT Challenge and part 2 of a snake game development on a microcontroller. My name is Thomas, and this is the channel that educates you on IoT and web development by showing how to build projects step by step. For more content like this, make sure you subscribe so you will be first in line when it comes to the channel updates and new videos. And now, let's get started. Here is the project from yesterday, right? I call it snake game, but it's not snake game yet. It's gonna be at some point. And this is what I've wrote to draw the pixels on the screen, essentially. And I'm gonna quickly go through it to remind everyone how this works, right? So we've got Adafruit ST7735. This object is to control the screen. We passed the pins we connected the screen to, and we've got our buttons and the pins we are connected the buttons to. We set almost all of them to input pull up except for the down button, which is input because I built the pull up myself. And that's to initialize the screen, fill it with a black color, right? So it's got a black background after running this method. And I set the rotation to 3, which is like that, right? Which is displaying it like that, right? If it was like that, then you would probably set a different rotation. And this whole functionality to draw the pixels is based on the point, on a single point. And that point is constantly displayed on the screen, right? It's drawn as a pixel on the screen, and depending on what button is pressed, that point changes its coordinates. And this new point, right, it just, you know, what we're doing here when the button is pressed, we mutate the state of the point, and then that new point is still the same point, but new coordinates, right, are given to the pixel that is drawn on the screen, right? So essentially the way this works is like that, right? It starts from a single pixel here. If you press up, it's gonna draw a pixel here. If you press up again, that's gonna draw another pixel. If you press right, it's gonna do that, and then up again, let's say, and left and so on, right? So that's how that functionality works so far, but that's not something we're going to be building today, because we want to display a snake and we want to make it move and control it with the buttons, right? So I'm gonna keep the if statements for the buttons. However, this point as an instance is not needed anymore, so I'm gonna remove it. We still need a struct though, because we're gonna use those coordinates today. I'm gonna show you how in a second. And this command, this instruction to draw a pixel, for now I'm going to remove it because we're gonna be doing it with the snake instead. Right, okay, so now we've got code. Yeah, the state of the code now is ready to start writing the functionality of the snake, right? But before I write any code, I'm gonna go back to this spreadsheet that I've created to explain how this how this all works, right? And what we want to do on the screen first, when the game starts, is to draw a snake, right? To draw a snake, it's gonna be pretty straightforward. So let's say we have a tail of the snake and we have the head of the snake. And we want to draw a line between the tail of the snake and the head of the snake, and that's gonna be a straight line at the beginning, because you know that's how I would start the game, right? So I would just have a short, straight snake to begin with. Okay, so I'm gonna start from tail. So let's say somewhere in the middle of the screen we're gonna have a T that's gonna stand for a tail, right? Then we have the body of the snake, and somewhere here we're gonna have head, right? And that's gonna be our snake on the screen. Nice. And now, how you move it in the most efficient way, if you think about it, this whole thing, right, again, it's gonna be about drawing pixels on the screen, right? So if I want to display that using my Adafruit library, I would probably do some simple for loop starting from a 1x point, right? So that's the x-axis, so that would start from 7, and that would end up on 14, and y would stay the same for the beginning, okay? So that's easy, right? But now, how to do the least amount of operations to move that screen, to move that snake, let's say, just one position to the right. And I'm gonna answer this. So what we can do is to draw a head here, change that to body, remove the tail here, and change that to tail, right? So this is how we move the snake one position to the right. Okay, if I want to move it now one position to the top, what I do, I add a pixel here, and I remove pixel from here, right? And then, you know, it can just continue on and on. And because like this is gonna be put on the loop function naturally, right? We want to put this on the loop. That's gonna look like, you know, depending on delay that we set to the loop function, it's gonna look like a movement on the screen, right? So adding a new pixel at the beginning of the snake and removing the last pixel like from the tail of the snake, and we'll see the snake moving on the screen. Nice, right? Yeah, let me show you. So yeah, you could do that, and that can continue, right? You can go up then, and because you always add one at the beginning and you remove one from the end, right? It's as long as you have stored the information where the body of the snake is, where is the head, where is the tail, you can do the whole movement, right? You can program the whole movement. But yeah, now the question is, how can we do it? And how can we do it with the most efficient way, with the limited memory on the microcontroller, and also with the least amount of the CPU instructions, right? I don't know if my solution is gonna be the best of the best, but I'm gonna try to make it as efficient as I can. So yeah, so as I mentioned, what we need is to know the locations of the body, right? We need to have a way to know like where is this, where is, for example, the head, right? We need to know where is the head to be able to draw the pixel in front of the head, right? So for that, let me go back to the code and define a struct. I'm gonna define a struct, I'm gonna call it snake, okay? We're gonna start from a struct called snake. Nice, okay, so there is a snake. And if we think about snake, for now, what we care about in a context of drawing pixel at the beginning and removing the pixel at the end. And what we care is head and tail, right? So head would be one thing on the snake, right? We could have something like a point, that would be head, and we would have a point that is tail, right? Let's put the body aside for now, right? So for the head and for the tail, we can get those coordinates, right? So we could even now create a constructor to this struct, and that constructor could even take, let me think about it. Yeah, it would be nice to have, is there any information that we pass about the width or height? No, we don't. So I can define those new. Let's define width, that is 160, and let's define height, which is gonna be 128, okay? Right, and we could take them as uint8t, and we're gonna start from a width, and then we will have 8t height. And even better, right, we can encapsulate all of this, so I can even make those private, actually. So we do something like that, right? And based on the width and height, we can draw something like this. So we do head x equals width and minus divided by 2 and minus something. And you know what? What we could do is to maybe take another. We could take another. Maybe I do it later. So let's just assume we have a length of 6. Okay, so that's gonna be head x, and y is gonna be height divided by 2. I'm gonna explain what I'm doing in a second. So tail x equals, again, hang on, that should be plus 3, and that's gonna be minus 3. And tail, actually tail y can be this, so even easier, right? We can have something like that. Okay, so now we have a nice encapsulation. So when you create a snake, let me actually even create it. So if I create a snake in here, that constructor, I need to pass the width and height. Yeah, when I create it, a constructor is going to determine where the head and tail is, and that head is gonna be at the middle of the screen, right? Plus 3. So I can show you here. So I'm not sure where the middle is in here. So that's gonna be at 11, position 11, and here we have 21. So that's probably gonna be 10, because we're trying to divide integer values. But yeah, anyway, so that it starts here plus 3, right? So that's gonna be the head in here. So it's 1, 2, 3. And again, that starts here, and the tail is gonna be somewhere here. So it's, hang on, 1, 2, 3. So this is where the tail is, right? And all the rest is gonna be the body, but we don't have the body represented yet, because I don't really want to have it represented on the snake, but I'm gonna explain why. So yeah, so that basically creates the head and the tail of the snake, right? So that's the structure, data structure that I have created first, right? And now let's go back and actually talk about the body, right? So on the body, first of all, let's consider the case where we don't really have any information, right, about these segments, like we've got right now. So we've got only head and tail, and you know, as it is very simple to draw a snake when we draw it for the first time, because it's a straight line, right? So as I showed, we've got the coordinate, the x coordinate of the tail and x coordinate of the head, and we just draw straight line in between, right? So that's easy. But what if the snake is not a straight line? What if snake is something like this? Okay, and now drawing a straight line is not really possible. We could try to do something in between like this, but as you can see, there could be many combinations for that. So for the body, we need to store the information. We need to store it somewhere in some container, right? But how can we do it in the most efficient way on the memory, but also on the number of operations? That's gonna be a bit for the future, to calculate the collisions, okay? And I'm gonna start from showing you the wrong way of doing it, right? Because like, if you think about how we represented the head and tail, we could actually follow this method and declare something like a body array. Okay, we could have a body array that would be the array of points. But for the array, you need to consider the case with the biggest possible array. And the biggest possible array in our case, that would be like super long snake going like this, right? Up to the very end. So that snake possibly could go up to 160 times 128, right? And on top of that, that's quite a lot of memory as for this little device that we program it on. On top of that, that's 2 bytes for every single point, right? We have X and Y. So that needs to be multiplied by 2, and that's gonna give us the whole memory taken by this container if we went this way, right? Which is not a lot, but still for that device, maybe it could work with that, but it's not the most efficient way again. And also on top of that, for the future, when we have to start calculating the collisions, right? So collisions is something like when we have the snake that is going to collide with its own body, right? And with this sort of array, we would have to go through, before every single move, we would have to go through entire array to check if that coordinates that we're trying to move to are not taken up by the body, right? So that's quite a lot of operations that you need to do. You need to iterate over it. Okay, so yeah, one improvement though could be to represent that maybe as a multi-dimensional array, right? But if you represent it as a multi-dimensional array, so you would have something like this, okay, that is not really helping us in a way of the integrity of the snake, because how are you supposed to know now which point on the screen, this field, is the previous one, which one is the next one, right? That's just going to be this matrix of that, but with no information. It's just information about the point, right? So you actually don't even need the point if you think about that. Instead, you could have something else, right? Because that gives you the point. That's X, that's Y, and here you could have information about something else, right? That's gonna be somehow our solution, but not exactly in this form, right? So single dimensional array for the entire snake, not a good idea, too much memory, 2 bytes. But 2-dimensional, that might be a good idea, but that's not the body anymore. That's not the body, right? This is not a snake body. Snake is a single dimension. It's not 2-dimensional if you look at this, like, you know, from the perspective of this game. But yeah, anyway, as I said, like this thing it doesn't belong to the snake, right? This is more about the snake reality, not the snake itself. So what we can do about it, like how can we represent then the snake in a different way, and also how can we use just a single byte instead of having a 2 bytes for every single segment of the snake. For that, we're gonna have to introduce separate multi-dimensional array, 2-dimensional array exactly, right? That's something I was thinking we are not able to avoid. So we need to consider this this amount of memory that I showed you before, like 160 times 128, as necessary to take up. If you know better way, if you know about better way, how can I do it without taking all the memory? Like considering the scenario with the longest possible snake, let me know in the comments. But I was thinking a lot, and you still gonna need that, right? So what I'm gonna do in the code is to create another struct. I'm gonna call it game. And this game would have an array. Let's make it maybe uint8t for now, as a single byte array. And let's call it field, as for the field, right? So this whole thing is just a field of the snake where the snake moves on. And that field would have a width and height, right? That would be the 2-dimensional array, right? Called game. Right, so with that, now we've got this thing represented, okay? And because now we've got a field and we have entire byte to use up, right? What we can do is to have a representation of something on this field hidden behind enum, for example, right? It can be enum, it can be characters, right? It's up to developer. I'm gonna go for enum because it's gonna be slightly easier to read. And I'm gonna create this enum and I'm gonna show you what I mean by all of this. So that's probably gonna be on the game, right? Yeah, that's on the game. So I'm gonna create the enum and I'm gonna call it maybe pixel. Not sure what's the best name. And that pixel can be one of a couple of values. We can have empty, we can have up, we can have left, we can have right, we can have down, and we can have head. So why this and why I duplicate myself right now? Because I already have direction on the snake. Let me show you. So empty is gonna be the whole space at the beginning, right? We will have zeros everywhere. We just have zeros like everywhere, right? That's gonna help us with detecting the collisions. Because if snake is about to move, and by the way, this is where the move is gonna happen. So we will have something like move snake in here, right? And when we move the snake, we can easily calculate if there is any obstacle in front of the snake. So if we have a snake here, that's tail, that's head, maybe here. There is head, okay. So all of these fields around are zeros, right? They empty. This one's also empty. But because this one is gonna be something else, and the head is at this position and the direction of the snake is down, then we know there is an obstacle in front of the snake, and essentially the game is over, right? We're just gonna stop the game because the snake just collided with its own body. And this array is gonna allow us for that, right? Because it's a two-dimensional, we will have instant access, right? Just single operation access. So we know where the head is, right? Let's say a head is at some point, right? In this case, we're gonna know that head of the snake is at point 99, right? X9, Y9. And direction is down, so we're going to increase the Y, and we check if the X9, Y10 is empty. And if it's not empty, collision, game over, right? So that's really good on the complexity of this, right? Because we can get it immediately, get the information. There is nothing that we have to iterate through to get that information, right? And also, this up, left, right, down, and head can represent in a relative terms, right? The previous idea where we had the array of points was the absolute, right? There was absolute representation of the body segments of the snake. But what we can do instead, and having 1 byte of information instead of 2, is to have a relative one. And that relative one is really gonna be like that. So if we have a snake, let's say somewhere here, there is the head, and here is the tail. And instead of the tail, there is no tail, as you can see, because it's not gonna be needed. But this is where is the end of the snake. But instead of having the tail, we will have information about the previous segment. So where the previous segment is, here, right? That's on the right. So I'm gonna put R. And now on this segment, where is the previous one? On the right. And again, and now the head is here, but I'm not gonna go straight to the head like this. I'm gonna show you something with all the directions. So we're gonna go to the right again. And now we're gonna go up. So we're going up, right? So again, relative, right? So up, the next one's gonna be here. I'm gonna go right. I'm gonna go right again. And now I'm gonna go down. So that's gonna be D. And then I'm gonna go right again. And again. And up. And up. Up. I'm gonna continue from here and now all the left. Right? So now we have a little bit more complicated snake. But as you can see, we have all the information needed to get to any segment of the snake, if you think about this, right? Because starting from the end of the snake, this is the tail, and we have separate place with information about it, which is here, right? The tail point. So based on that, we can essentially go to any place. So from here, we know we need to go right. So right means increase the x, increase the x, increase the x. Here, increase the x. And now from here, it's gonna be decrease the y because we're going up. And then we're going right, right again, down, right, right, up, 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 left, 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 left. And this is the head. For the head, I have a separate value because I don't know yet where this head is gonna go. I don't know yet, but I will be able to tell based on the direction of the snake, right? I will be able to tell. So yeah, so this is essentially how this is gonna work. But one more thing is the movement, right? So how are we gonna move? So movement based on the direction, we can tell where the head is gonna go. So where to draw the next pixel. So let's say now is up. With this representation of the snake on the two-dimensional array, what we're gonna do is check the direction, right? So let's say it's up. And because it's up, we know we need to change this particular segment to up and add the head in here. And then taking it from the snake itself, right? We can read the tail X and Y. So we know it's here. What we do, we check what is the value of that field, X and Y, and the value is R. So we need to go to the right. And from the right, we can change that to tail, right? So we change the segment, the segment before the last one. We change it to the tail, right? So we change the tail location and we can remove this one, okay? And I think it's gonna be easier to understand when I code that, but essentially that's how it's gonna work, right? So again, maybe I'll show you with the T instead of R, but there is like, you know, T, maybe I do R and that's T, okay? Something like this, that means is a tail. So now we're gonna move, let's say we're gonna move left now. So what's gonna happen is we can change that to left because we know we're moving left, that's the direction. I'm gonna write a head in here. And now what we need to do is to determine where is the segment before the last segment. And it is on the right from the tail. So what we're gonna do is go to the right, then change that segment to tail and remove that segment. And that's exactly what's going to happen in the code. And let me move to the code and implement it right now. So I'm still gonna use game struct in here. And the game struct is going to be a friend of a snake. Because I would like to have some nice encapsulation. But yeah, having a head and tail private in here, I'm gonna create a method to provide them, right? In case someone wants to get that information. That's the other way around. Okay. Get tail. Return tail. Right, so we got that. Okay, so yeah, friend, what does it mean? That means if we pass the snake, which we're going to pass to the game, we will have access to the private members. From the game only though. So So here I'm gonna take a snake, a reference, because we're gonna be modifying it. And we're gonna need a private member of a snake in here. Snake reference. Yeah, I keep doing this instead of this. So yeah, that's gonna be something like that. Okay. So that's gonna be our game. And yeah, field can be now private as well, but move snake is not going to be. For the snake, it would be nice to have a set direction method, right? So we can tell what is the direction. So what I'm gonna do is to do something like that. Set direction, and that's gonna take direction as an argument. Let's put the enum at the beginning. Okay. Nice. And this was, I'm afraid, the last method I implemented today. The rest on the subject tomorrow. If you enjoyed it and you find the value in my content, don't forget to subscribe so you will stay up to date with my channel. Thanks for watching and see you tomorrow.